Hello, welcome to our final Q&A of Services at Scale. I hope you enjoyed the presentations that we just had all about the developer experience. We have our experts here and we're gonna be taking your live Q&A questions and seeing what they have to say. The first question today is for Robert, coming to you from Vastov. How do you scale your software development approach to allow multiple teams to develop the applications together? And this is about Service Weaver again.
Yeah, thank you. This is a great question. Actually, this is a good case where you don't want a single Service Weaver application and you need multiple applications. So in general, based on our observation, we realize that even within a team, there are many services and people just write too many microservices, and that's not needed. I think what we argue for is like if Service Weaver, you can reduce the space of these services, and ideally you should have a single binary per team. But now if you have cases where you have to split your application across different teams or even maybe different programming languages, then you'll still need multiple binaries, Service Weaver binaries, and then you can use a service mesh or something to glue them together. And actually we are working on a solution to address this problem, but we don't have it now.
The good news is there's always hard problems to work at, especially when you are working on big problems. Another question for Service Weaver talks about the 9x reduction in infrastructure costs, and I was actually pretty interested in this too. How was that computed?
Yeah, so we ported like a online boutique application, which is a very popular application advertised by the GKE Google Cloud folks here. So we basically, the application has 11 microservices. We ported the non-Go services to Go as well for a fair comparison. Otherwise, the numbers would be even worse. We run this application in Google Cloud on GKE, and we use the horizontal pod autoscaler both for our application and the GKE version of the application. So like almost half of the gains came just doing an apple-to-apple comparison, like running distributed Weaver, like every component separately in a different process, and vanilla, like the Kubernetes app, the GKE version of the app. And the other half came from collocation. Because of Service Weaver, we are also able to collocate at runtime some of these components, for example, if they are chatty components. The main reasons for reduction are our custom encoder and custom transport protocol we have, which are very, very efficient.
That's great to hear. And thank you for sharing that. I'm going to change gears a little bit and ask some questions about prod spec and annealing, especially as we're talking about the number of binaries. So Pierre, there's a question from Vastov about would prod spec be able to handle the change in the infrastructure where the hardware is more heterogeneous and resources are more disaggregated?
Yeah, thanks. I don't think there is any fundamental problem with the heterogeneity here. Today, prod spec and annealing are already dealing with many different types of resources. So we push things to eventually to switches, for example, like hardware switches. And if we ended up with having to update different type of computer connected on different ways and so on, that will not be a problem as long as there is a connection. There is one limitation we've seen lately, which is when your heterogeneity leads to delays, meaning that you cannot easily go to a server, well, not physically go, but push something directly to a server or not read it directly from it, but you have constraints that, oh yeah, you need to wait a few days before having access to it for security reasons or variations thereof. Here, that's a case where the intent-based work is a bit more difficult. We are a bit more struggling to make it work. But otherwise, in general, that is fairly adaptive.
And so what is the biggest challenge that you have in prod spec today, would you say?
So on the modeling side, also on prod spec itself, on the modeling side is the amount of data. And while the principle of having a generation pipeline is sound, and I will do it all over again, we have a lot of data, and generating or intent regularly tends to be slow, and that impacts negatively or developers' productivity, for example, and that's something that will need to be improved. I don't believe there is a fundamental problem with that. It's just our implementation which has limitations. Another aspect of the modeling is the frequency of changes. it turns out that production configuration is a lot more dynamic than people think of. That was also our case. We thought that it's mostly stable. We just change it from time to time. It must be a lot faster. And our system was not initially designed for that. On the enabling side, so on the enforcement side, so once you have the intent, what to do with it, something which is complicated is this notion of select, update, validate is great when you have only one of them, but people think in terms of different layers, high level or description of your service, low level description of your service. And here we're still trying to figure out what is the best approach. Should there be only one loop, like one select, update, validate, which takes care of everything, but then everything is mixed up, it starts to follow, or should there be different loops, but then how are they integrated, I would say, synchronized? So that's some things that we are iterating on those days.
That makes sense. Thank you so much. And then I want to shift over for a minute to TJ, talking to us more about the Thrift Meta Journey, or the Thrift Journey at Meta. The question again is coming from Gustav, who is obviously listening and asking us lots of great questions. So thank you for that, Gustav. Was gRPC one of the RPC frameworks that was included in the Thrift unification? If not, could that be done today?
So the gRPC was not the protocol we unified the Thrift. So however, if we want to do that today, what we will do is usually we will create a Thrift server in parallel so that the client can use both either gRPC or Thrift. And of course, we need to check whether Thrift provides all the features. If there's a missing feature, we also need to implement those missing features first and fix any performance issue. After that, then we will slowly migrate the client from the gRPC to Thrift. And eventually, we can remove the gRPC service. So depends on how widely it is used. This might take multiple years, so it's definitely not something. It's definitely not a small project.
And so, in talking more about the Thrift APIs and how things are used, did we ever make any non-backward compatible changes to any of the widely used Thrift APIs? Like, how is that done? This is for TJ as well. Sorry.
Yeah, and so I think gRPC could consider one of the non-backward compatible changes. And yes, Thrift, we made multiple non-backward compatible changes in the past. And what we do is similar. Basically, we create a new API, but we still keep existing API as it is, so that the user can use either old one and the new one. Then we have some refactoring tools to migrate user's code in Meta to the new API. After the migration is done, then we can remove the old APIs. So sometimes it's not possible to create a new API and the old API at the same time because, for example, the old API and the new API, they have some signature, but they have different behavior. So in that case, sometimes we need to create an intermittent API. So we first we migrate the old API to the middle layer first, then migrate the middle layer to the new APIs.
We have another question for Robert with Service Weaver. Can you explain how components communicate with each other when all are deployed to Kubernetes?
Yeah, that's a good question. So by default, every component exports like an internal listener, which is the address where each component or component replica is reachable by other components. Now it's up to the deployer or the runtime to decide how to discover these addresses. So for example, for the local machine, all the components will just export the addresses. They will listen on the local machine on a random port. But then for like Google Cloud Deployer or Kubernetes, when we create the services around these components, we basically also specify at which address and at which port you want to listen, because having the same port across all the replicas for a component is important. And then, so when you start these components, they know on which port they have to listen. So, for the internal listener. And then when we start this, we have like a sidecar proxy, which goes like the application. We also inject, the addresses of all the components this particular component has to talk with. So that's kind of how we do it.
Thank you. That makes sense. I'm going to move to Pierre and ask a question about ProdSpec again. It is an interesting technology for sure. So can you tell us more about some of the biggest success stories for ProdSpec at Google? And if there are any hiccups in the rollout and adoption?
Yeah. So the biggest success story is that it's used for almost everything within production. And honestly, when we started that, we wanted to push a couple of jobs in the right order because sometimes there was a subtlety. We wanted to automatize that. And we started with that, and now it's used for everything. And particularly one part which I am very happy about is that it's used to enforce anything in production. So not only jobs running, like binaries running, those are quite often automatized in many places and in many cases. But here we're enforcing anything, like any type of configuration. We are basically not doing anything manually to our production in many cases. And that includes even like the firmware of network switches, where ProdSpec and handling are involved. So that's worked very well. Hiccups, yeah. Yes, when it comes to dealing with production automation, there's that can indeed happen. In general, I think that really improved the reliability. However, automation is really good at taking a small failure, something which would have been small, and then suddenly making it a big problem. And those network switches, for example, at some point there was a belt firmware being rolled out. We stopped it, and there was a tiny bug somewhere in a stack, and suddenly the rollout started again. And that was very much not a good time for us to understand, okay, why is that starting? We've stopped everything, but it's still going, it's still running, it's automated, so it just proceeded with it. Luckily, I think most of the problem we had were mostly internal. We are not visible externally, which is good, but we try to spend quite some time thinking about the various failure mode and reducing the speed at which things go to avoid like suddenly deleting tons of data or turning down tons of jobs.
Automation can be a big blessing and also a big troublemaker, depending on how it gets rolled out and how quickly. I'm going to roll us back over to Thrift for a moment. And a question for Dave. What is the main difference between Apache Thrift and FB Thrift, in your opinion?
Yeah, so this is a common confusion. Like when people say using Thrift, I guess there's Apache Thrift and then the Facebook Thrift, the new version that we're developing. So adding up to what Nandhini presented, Apache Thrift was released in 2007 as a part of an Apache incubator. And we released Facebook Thrift in 2012 to meet Meta's infrastructure needs. The main difference was that at the time, we wanted to improve the asynchronous workload performance and added more per request information. And since then, we added like many more new features in Facebook Thrift, including like safer usage of IDL, streaming, and more. Yeah, so feel free to check out our GitHub repository for the Facebook Thrift.
Thank you, Dave. Robert, talking about different languages, are you planning to handle language heterogeneity in the future with Service Weaver? If so, is that compatible with the Service Weaver design?
Yeah, this is a great question, and the answer is yes to both questions. So the nice thing about Service Weaver is like it does a really good job of decoupling the programming framework from the runtime. So we can have runtime, different implementations of runtime, for Kubernetes, for WASP, for whatever, and then we can have programming framework in whatever. Right now it's just Go, and I think for now we plan to stick with Go because we want to focus more on the quality and more features and to make the framework better. But nothing prevents us from doing other languages, and we have a lot of requests for that. It's just we are still a small team right now, and we are prioritizing more important things. But yes, there is no fundamental limitation, and actually we are welcome always, people from the community to engage with us and contribute if they want.
That's great. And then Robert, we have one more question for you as we round out the questions here in this Q&A. Using Service Weaver, can the application be deployed on local, Docker Compose, or Kubernetes and Docker, also known as K and D cluster?
Yeah, Kubernetes and Docker for sure. The Docker Compose, I'm not sure if it just goes by like simply running it right now, but I think it will be easy to do that. Right now, I think the only thing is like, we run Docker containers for all our deployments, and we have a vanilla Kubernetes deployer, so you can deploy it in any environment. Docker Compose, I never tried, but it should probably work.
Sounds like a thing to experiment with. All right. Well, I want to say thank you so much to our experts here, answering all the questions that we had in our Q&A. It's been great, and your presentations were all wonderful. So folks can take a look at those if they need to. Again, they are going to be up online. We have some closing comments from Hui, so please stay tuned.
That marks the end of the technical program for Systems at Scale, summer 2023. I want to express my gratitude to all of you for joining us. I extend my appreciation to our speakers for generously sharing their expertise. I hope their insights will continue to inspire you in your endeavors to build large-scale distributed systems. I look forward to reconvening in the near future as we strive to push the boundaries of what's possible in planetary scale computing. Thank you, and until we meet again.